Hey guys, I'm back again. We are doing Coachbook lesson 33 today. It's talking about drawing figures, and this is going to help us keep reviewing some of these new geometry terms we've been going over. So the first thing I wanted to show you, if you are having trouble with angles, because we've been working on right angles, obtuse angles, and acute angles, you can actually use a piece of paper or anything with a 90-degree angle, an index card, your math book, and you can check angles this way. So, for example, I'm going to start and show you. This is our right angle. It's 90 degrees. And you see if I put my paper up next to it, it perfectly follows both edges here. We can check, and then we know that that's 90 degrees. Now, if I line my paper up on this angle with the bottom ray, you can see that I cannot see that other ray, the top one. So then I know it's acute because it's smaller than 90 degrees. The same thing works for the obtuse angle. If I line it up with this bottom ray right here, you can see that instead of following this, it's wider than a 90-degree angle. So if you're having trouble, that's something you can do. You can find something around your house that your math book will work to use to help you determine what kind of angle that is. The other thing I wanted to review quickly with you guys is if I have something like this, that is considered a line. It's considered a line because if you look, these two arrowheads right here mean that this is going to go on and on and on in both directions endlessly. So that is just a line that is going to go on forever both ways. But then, on the line, it's made up of an indefinite amount of points. But let's say I do a point here and a point here, and I name this point A, and then I'm going to name this one point B. Okay, and those are just 2 points on my line. But if I were to take just this part from point A to point B and put it down here, so we'll name A and B. Now I have a line segment. And we know it's a line segment because there are 2 endpoints. And the word segment actually means piece. So this is a whole line. This is a line segment with the 2 endpoints because it is just a piece of this very, very going on forever line. Then we have this. If I were to take from point A going on this way, now I have a ray, because it's not going on forever this way now. We have an end point here, and then it continues on forever this way. That's why it's a ray. You can even put, but then on this ray, there are still all of these points. There's an endless amount of points going on this way, but it only goes on forever in one direction. So we have a line segment, which is a piece of a line, or we could have a ray. And then, if we add another ray, now we have created an angle, okay? So when you have 2 rays that come together at this vertex point, you create an angle. The last thing I want to show you before we get into the Coachbook is intersecting lines. So let's say we have a line like this, and a line like this. These are considered intersecting lines because they intersect at a point. They cross over each other. They are not perpendicular though. They do intersect, but for intersecting lines to be considered perpendicular, they have to look like this. They create 90-degree angles. And again, you can still use your notebook paper trick that I showed you. So when I do this, these lines create a 90-degree angle, so I know they're perpendicular. If I line it up here, there's nothing lines up this way on these intersecting lines, so we know that they're not perpendicular. Parallel lines are the up, so we're doing perpendicular and parallel. Parallel lines look like this. And they don't always have to be stacked like that. They could be facing in any direction, but they are never going to touch because they're just going to run alongside each other forever and never meet up. When I talked to some of you on Zoom, we talked about, can we find parallel lines within a polygon? So look at this. In this one, this set of lines is parallel, because they're both going to go on forever and ever without touching. And then the top and the bottom are parallel, because they're going to go on forever and ever without touching. And I told a lot of my students this week that I spoke with, think about it like railroad tracks. If you were looking down a railroad track, those metal pieces that run along the railroad track, they go on and on forever and they're never going to touch. So that was just a quick review, but we are going to go jump into the Coachbook now and look at lesson 33. So if you don't have your book, go ahead and pause this video and grab that. Okay guys, we are in your Coachbook on page 314. We're doing lesson 33, which is drawing figures. We are going to draw some of these figures together, and I think that's going to help some of you. By drawing them, I think you're going to be able to identify them when we go to do our assessment. So, the first thing we're going to look at, it says, a point is a location in space. A capital letter is used to name a point. So they show us point X. Alright? So I want everybody in their book to just draw another point. Just to help you remember. Draw a point. And you can name it anything you want. You could name it the first letter of your first name. I'm going to name mine point B for Ms.Bowling. But I want everybody to just draw a point and name it. So I have point B, you could have point A, point F, point G, but just draw a point in your book. It's important to know, okay, so points are the building blocks of geometry. So they are our smallest unit in geometry. And everything else is made up of points. So like when you see a line, they're naming this point, but the whole line is just made up of point, and that's what creates the line. Okay, so, and that's what it says right here. A line is made up of many points that extend without end in opposite directions. A line has no thickness, and then you see how we name it? We name it, so we have 2 points on this line, A and B. So you can do AB and then you draw a little line. That means line AB. And it doesn't matter what order you put your points in. You see they did it here, BA with a line over it. So I want everybody underneath that line to draw their own line. And I want you to put anywhere on there 2 points. And for Ms.Bowling, I'm going to do M for Miss and B for Bowling. So now I have line MB. So once you get your line drawn and you get your 2 points, then I want you, how you would name this is we would draw a little line like this, and then underneath it I'm going to write MB. So now I know that that is line MB. Alright, so then it says a line segment is part of a line. It's made up of 2 endpoints and all the points that form the line between the endpoints. So they did their line segment and they named it CD, and you can see there are no arrows on the end, so that's how we know it's a segment. So when you're doing a line segment, notice the difference. Up here they used arrows on the end to name it, because it's a line. When it's a line segment, you do not put arrows when you name it. So now I want everyone underneath here to draw a line segment. And you all know my daughter's name is Lily, so I'm going to do L and B for Lily Bowling. And then next to it, I'm going to name it. So I'm going to do an L and a B and do my line over it just like that. No arrows because this is a line segment because it starts and stops at a certain point. Now, the next one we're going to look at is array. Array is also part of a line. It has one endpoint and it extends without end in only one direction. They named theirs EF. So, and then when they were naming it like this, they put EF and they just drew a little tiny ray over it. So I want everyone to draw a ray. So you're going to draw a line, and it's only going to have an arrow at one end. The other end is going to have an end point, and we're just going to draw another point somewhere on our ray. And I am going to name this ray XY. I'm going to name my points XY, so then when I go, I want everyone, you pick whatever letters you want to use. And then next to it though, because I named mine X and Y, I'm going to do an X and a Y. And I'm going to draw a ray over the top. So then we know that that is ray XY. And if you need to pause this at any time to catch up and do this, go ahead and do that. Alright, so for example 1, they're having us draw ray PQ. And we know that because there's a, let's circle it, there's a little tiny ray over the top. So to do that, we have to draw an endpoint, and we're going to do this along with them. So they drew endpoint P. Let's also draw endpoint P right here. Then they said draw a different point. They chose Q. It doesn't matter. You could choose whatever letter you want. But let's also draw a Q. And we're going to do ours the opposite way they are. So you can see that a ray can go either way. So now that we have Q, then it says draw the ray. Start at endpoint P and draw a line through Q. And then because it's a ray, we're going to have to do an arrowhead. So I'm going to use this protractor to do mine. If you don't have a straight edge you can use, you can just do it to the best of your ability. Alright, so they drew their ray going the other way, but it doesn't matter which way we draw a ray. So, yeah, that's how we do a ray. Notice it ends here. This way it's going to go on endlessly. Okay, so then looking at page 315. So an angle is a figure that is made up of two rays that share an endpoint called the vertex. Right, so let's circle the vertex and underline it. And then if I were to cover this up, you could see that there's one ray, there's the other ray. When they meet together like this, they form an angle. So draw that in there just so you know. They have, because these two rays meet back here, they've formed an angle. Angles are measured in units called degrees. We all know that's the symbol for degrees, that little circle next to your number. And you can classify an angle by its measure. And I showed you this earlier. So, remember, right angles are 90 degrees. And if you have a sheet of paper or anything else, you can put it on here and see that it lines up. Acute angles, remember, they are acute because they're smaller than a right angle. And then an obtuse angle is greater than 90 degrees, right? So our obtuse angle is our big angle. It's bigger than 90 degrees. It's important, yep, they're having you look here at this box. Everyone, I want you to draw over that box to help you remember. When you see this symbol here, that is telling you that it is a right angle. All right, let's look at example 2. So they want us to classify each angle of STUV as acute, right, or obtuse. So you'll notice they took this, so I want you to underline it. They labeled this figure by talking about these 4 points. So circle those. And they want us to look at each angle inside of here, okay? So the first one, they're telling us to look at angle S. Well, S is right here, so that's this angle. And what we notice is that little box that we just talked about is here, which means the box symbol indicates that the measure of S is 90 degrees. So S right here is a right angle. The next they asked us to classify T. So we have to go look, here's T, so now they're talking about this angle. And they've told us that it's 139 degrees. So 139 degrees is greater than 90. And when we have an angle greater than 90, we call it obtuse. Next, they're having us classify angle U. So we're going to go up here. Here's U. So that means they're talking about this angle right now. And we know that they're telling us it's 41 degrees. Well, 41 degrees is less than 90. And if you look at it, look how small it is. It's smaller than 90 degrees, so we call it an acute angle. The last one they're having us do is angle V. So if you go up here, look at angle V, and then look again, we see that box. And they're telling us the box symbol means that angle V is 90 degrees. So then we know that angle V is 90. All right, let's look at this one. It says 2 lines intersect to form right angles that are perpendicular lines. So remember, they're intersecting lines, but because of the way they're intersecting, they're perpendicular. They make 4 90-degree angles. So you'll see how they named this AB. So this is line AB, and we know it's a line because there's 2 arrows on either side. And they're calling this line CD, C and D. Again, we know it's a line because of the 2 arrows. And they're saying AB is perpendicular to CD. And right here, if you want to circle this, that's how you say that 2 lines are perpendicular, by making that little upside down T. Now we're going to look. 2 lines that never intersect are called parallel lines. So see, way up here, these, and they're calling this line EF. So you see how they did that here? They did the E and the F and drew the little line symbol over it. And they were saying it's parallel to line GH, which is right here. And then when you want to write that, you're going to put line EF is parallel. So it's just you draw a little set of parallel lines to GH. And that just means these are never going to touch, because this one's just going to keep going, and this one's just going to keep going, and they'll never touch each other. All right, for example 3, it says the figure shows an overhead view of 4 streets that surround a local high school. So this is your high school, and these are the 4 streets. They want us to identify 1 pair of parallel lines and 1 pair of perpendicular lines. All right, so for step 1, they're saying we need to find 2 lines that do not intersect. Well, if you look up here, this line and this line are never going to intersect. So line JK, so line JK and line TR are parallel. Now, to find perpendicular lines, we have to find 2 lines that intersect, but they can't just intersect. For them to be perpendicular, they have to make 90-degree angles. So this one intersects, but look at these angles. They don't form 90-degree angles. But look here. So let's draw some boxes to show that this is forming 90-degree angles, okay? So now we know that line KR is perpendicular to line TR. So KR is perpendicular to TR. KR is also perpendicular to JK. And again, that's how we write that. This is the last example. There's one more in here. So it says, name the following parts of the square ABCD. All right, so the points that are labeled on here, let's draw our points. That's a point, A's a point, B's a point, C's a point, and D's a point. So we've done our points. Now let's talk about line segments on this. So because this stops right here at these points and it doesn't go on forever and ever, it's a line segment. So we have line segment AD, which remember when we do that, we just write it like that. We have line segment AB. We have line segment BC. And then we have this line segment CD. So we have 4 line segments that make up our square. All right, then for angles, so we have angle C. So when you do that, you just draw a little angle, right? We have angle D. We have angle A, right here. And then we have angle B. So those are our 4 angles, and if you'll notice, because we have a square, these little boxes tell us that they are all right angles. So we've labeled our angles. Now we're going to look for parallel segments. So if you look, A and D and C and B are parallel because they're never going to touch. So we'll do DA is parallel to CB. And remember, we just do those 2 little lines right here that show us that it's parallel. Also, C and D are parallel to B and A, right? Because these are never going to touch. So DC is parallel to AB. And remember, it doesn't matter what order you write the letters in. So we've done our parallel segments. Then for perpendicular segments, anywhere where they form this 90 degrees. So let's say line segment DC, you look at that, DC, it's perpendicular to CB. So we do that little upside down T to tell us that it is perpendicular to that line segment. And then this CB is perpendicular to BA. Do you see that? Because it forms another backwards L. So CB is perpendicular, which we use an upside down T, to BA. All right, and there's a couple more, but I just want to go ahead. I think you guys get the idea. I want us to go ahead and look at our coached example. All right, it says, name the following parts of the figure. So for this, first fill in the blank says, a point is so we're going to write location. A point is a location in space. And then it says to name the labeled points in this figure. Well, all these spots where you see letters are the labeled points. So right here we're going to write J, K, L, M, and N. Then it says a line segment is part of a line. So remember, it's a part of a line because it has two endpoints. It has a start and a stop. So then they want us to name all of the line segments. Well, there are a bunch. So let's just start here and work our way around. So we have J to K, starts at J, stops at K. So we're going to write JK and we're going to do our line segment. Then we have K to L. So we're going to write a K and an L with a little line segment. Then we have L to M. Just like that. Then we have M to N, right here. And then we have N to J, like that. And our last one, M to O. Now we've labeled all of our line segments. Then it says array is part of a line, and it only has one endpoint, right? Because it has one endpoint, and the rest of the array, if you say from here, O is your endpoint, it goes on and on and on and on and on this way. Then it says to name a ray, name the rays in this figure. So we could start here because this is a point, and we could say we have ray MO. So we're going to do an M and an O with a little ray over it. But we could also start our ray back here, and then we would have ray LO. An angle is formed by two rays, right? Because when two rays join, they share one endpoint, and that's how they make an angle. Let's just name one of the angles in this, okay? So here is an angle, right? From, if I were to extend this for you guys, that's an angle, and we can name it with N, M, and O because those are 3 points on the angle. So you're just going to do a little angle, N, M, and O. There are a ton more angles because there's, like, if we were to do this, there's an angle here. So if you want, you can go and find some more angles and name them in there. The next part says parallel lines are lines that never intersect, right? Parallel lines are never going to touch. They want us to name the parallel line segments in this figure. Well, if you look right here, do you see how these make that railroad track like I was talking about? Those are never going to intersect. So we'll call it line segment KL. So we write a K and an L with a line segment symbol. Then we do our two little lines, which means it's parallel to NM. We write that like that. Then it says perpendicular lines are lines that form right angles, is what we're going to put in here. All right, and it says name the perpendicular line segments in this figure. We're just going to go ahead and name one set of perpendicular lines. So we have right here, this is perpendicular to this. And you know that we'll put a little square right there. So line segment KL, we're going to write like this, is perpendicular. So remember, we do our little upside down T to line segment LM. Right? Because they're forming a 90-degree angle. You see there's a 90-degree angle here too. But we're just going to go ahead and do this one. Alright, so the parts of a figure are, alright, they want us to just rewrite all this up here. So our points are J, K, L, M, and N. Our line segments are JK, KL, LM, MN, NJ, and MO. Our rays that we talked about up there are MO and LO. We're just going to write the one angle we named just to save time. Our parallel segments that we talked about are KL is parallel to NM, and then the perpendicular one we named line segment KL is perpendicular to LM. Alright guys, I know that was a lot, so if you need to pause or if you have questions, please reach out. What I'm asking you to do today is just on here 1 through 7. Alright, and if you could try to take a picture of both of these at the same time, just use your camera, like put it over like this, and just take a picture of both and submit this one as just one thing, that would be great. And if you have questions, let me know. Thanks.